Hi everyone, this is Alicia Mars with the National Integrated Drought Information System. I am the Regional Drought Information Coordinator for the Western Drought Early Warning Systems and sit in Boulder, Colorado at NOAA. So we just wanted to welcome all of you to the August California-Nevada Drought Early Warning System Drought and Climate Outlook webinar. We are recording this webinar, so it will be available on drought.gov. Probably in a week or so, and we will also be developing a short 2-page summary of the information shared today that will be distributed by the end of this week. So I'm going to get started. Can we go to the next slide, Amanda? Please don't let me. Sorry. There we go. Thank you. Can you go one back? Great, thanks. So just to kick things off, for those that may not be familiar with NIDIS, I wanted to just give you an overview. NIDIS, the National Integrated Drought Information System, is a NOAA program, but we have an interagency mandate from Congress to help coordinate drought information research and just general coordination to improve our stakeholders' abilities to respond to, manage, and mitigate drought. So to do this, we've set up and are in the process of setting up a series of drought early warning systems at the regional level because we recognize that the needs of each region are very different in terms of drought. As drought comes to everyone in every part of the country, and right now you'll see that there is quite a bit of drought happening in New England where we don't actually have a drought early warning system set up yet, but there are specialized needs for each of these regions. Each of these drought early warning systems is set up to help improve access and the dissemination for drought early warning information, which is climate and drought information, and help people better understand that information in science so that they can use it more effectively to make decisions to mitigate drought. And through this process, we're trying to use all these regional drought early warning systems to set up a national drought early warning system, ultimately. Go to the next slide. And so if you've been familiar with NIDIS for a while, you'll know that we had a California drought early warning system, but as we set up this national early warning system, we're filling in those blank spaces on the map, and Nevada was the next step. So this new California-Nevada drought early warning system is coming together right now, and these drought early warning systems, as I mentioned before, are a way for us to utilize new and existing partner networks to help capitalize on the already existing expertise and resources at basically every level of government and then also in the private sector, academic sector, to really, really increase the capacity, again, of our stakeholders to better use climate and drought science to mitigate drought. So there are a lot of pieces that go into these drought early warning systems, and again, each one looks a little bit different based on what region it represents and the stakeholders involved. So this new California-Nevada DEWS, and that's how we refer to them in typical government acronym language, is building off of the original California DEWS that was established in 2011 roughly, and then also the efforts happened recently last year in Nevada when Governor Sandoval held the Nevada Drought Forum, which was replicated off an effort that he did as chairman of the Western Governors Association for a region-wide in the West drought forum. So there were a lot of really great stakeholder forums and information that came to be as part of his Nevada Drought Forum that are helping recommend or provided recommendations that will help guide the efforts that we build off of to create this California-Nevada DEWS. And so one of the products that's coming out of all of these regional drought early warning systems is the development of strategic plans for each specific DEWS. So we are in the process right now of ramping up the development for a California-Nevada DEWS strategic plan. There'll be a series of outlook meetings, including some stakeholder engagement and strategic planning exercises associated with those throughout this fall. And the plan is to have the strategic plan finished by the end of this calendar year, and these are 2-year living documents that will help provide a roadmap for what each DEWS has planned for each year and identify key partners and stakeholders. So we can be a little bit more transparent in what each drought early warning system is doing and offering the stakeholders in the region. So I will pass it on again. Thanks, Lucia. So my name is Amanda Sheffield, and part of working on these regional drought early warning systems is working and partnering with groups in the region. And for example, one of them is us here at the California-Nevada Climate Applications Program, where we provide climate information for decision makers in California and Nevada. And we're based at several universities in California, Nevada, primarily at Scripps in La Jolla and at DRI up in Nevada. You can find examples of some of our products on our website, but things that we're doing to support the drought early warning system are these timely two-pagers, such as upcoming ones on seasonal forecasting and La Nina, and also working with NIDIS to host several in-person events like Alicia mentioned. One of these, the first one we just want to tell you all about before we get started back on the webinar, is on Thursday, September 15th in Riverside, California. It's going to be an in-person version of this Outlook with more regional specific information, and also have a chance to hear from attendees on drought impacts and informational needs. And then with that, I'm going to get back to today's webinar agenda. First up, we're going to have Kelly Redmond from the Western Regional Climate Center give us the drought and climate update for California, Nevada. Then we're going to move into the seasonal outlook for the winter of this winter with David Pierce from Scripps Institution of Oceanography. And then wrap things up with Mecca Anderson, who's our state climatologist for California, talking about drought impacts. I will note we tried to get the guy, the state climatologist from Nevada, to talk about their drought impacts, but he wasn't able to make it today, so hopefully we'll have him on next time, because this is the first webinar, which is going to be a series of webinars to keep you guys informed throughout the water year this year. And before I switch over to Kelly, I'll also mention we will have questions and answers at the end, so please just type in your questions into the chat box and we'll keep track of them, and then we'll hopefully be able to get back to them for 10 or 15 minutes at the end. With that, I'll transfer it over to Kelly, who's going to do our first presentation on the current drought and climate status update.
Okay, can you hear me, Amanda, okay?
Yes, and I just passed the screen over to you.
Okay. Okay, you see that all right?
Yes, you're good to go.
Okay, so what I plan to discuss here is an overview of how did we get where we are, the current status, is there anything unusual about the current drought? What can we say about the upcoming winter? And most of that will be Dave Pierce, who will talk later. We have a La Nina coming up, that's wound up into the previous item. And anything having to do with, well, we're just about done with summer, and then if we want to have a short discussion. So this is just a recap, to show how we got here. This is the last good water year that we had, really good one. This is 2010 and 2011. Blue is wet and red is dry on these maps. We had a very wet water year in 2010 and 2011, and then that was followed by the following water year, October through September. Very dry in especially California and Nevada, but a good part of the West, except for the Pacific Northwest. Continuing on to 2012 and 2013. Same thing, especially in Nevada and California, quite dry. Another dry year, 2013, 2014. You can see there's other stuff going on in other parts of the map, but one place that's consistently dry is California. 2014, 2015, same thing. There's little pockets occasionally of wet conditions in Nevada, but California has been chugging along mostly consistently dry through this period. So this takes us up through the water year up through from October 1st last year to August 20th of this year, and showing a precipitation percent on the left-hand side and the temperature departure on the right-hand side. You can see from the precipitation map that we've had relatively decent precipitation, better than in the past years, and also in California. same thing, except for south of the line from about Santa Barbara on south. Temperature-wise, it's been modestly warm, not extravagantly warm like it was the previous year, but we had another warm winter. Of some interest has been, especially in the Great Basin, but also lopping over in parts of California, is May of 2015 was exceptionally wet, and it was really a standout month. That really did help in places that didn't get enough wintertime precipitation. This is May of 2015 for precipitation. And we were wondering if we're going to get a similar thing for May of this year. Well, this is that map. And yeah, we did get some extra precipitation, but not a great deal more than usual. But there is, and especially along the east side of the Sierra Nevada and on down into the sort of the desert areas in the southern part of the region. For June of 2015 was also quite wet in the western Sierra Nevada, or sorry, the western Great Basin, this area right here. That did help. And then there's, you have to take these with a grain of salt because climatology is one drop, and this says we got 2 drops. So because it's a very dry time of year here. So that's June of last year, and this is June of this year. We did have a somewhat similar thing happen. There were wet pockets in the Great Basin, especially the southern Great Basin, and then on into the northern part of California. So here's where the drought monitor stands right now. We've been slowly nibbling away at it. The areas here that were in the deeper reds have shrunk some, and currently the area in the deepest drought is this area right here, from about Los Angeles on north to Monterey, and then extending up toward, but not quite reaching Sacramento. And then we've had, you add up over the last 4 years, this is from a year ago, we were behind by about 1 to 2 years worth of precipitation, so it's a lot of deficit to recover from. Some of the reservoirs recovered reasonably well. Shasta here, Oroville, and a few of the lakes along the west side of the Sierra Nevada. It wasn't great everywhere, but this is one of the places where we really need water in California, and it did fall there. Looking at time series history, this is the water year precipitation going back to 1895-96 on through last October, and you can see these dry years right here, and then this is for the water year, and then for the snow season, October through July, we had those 1, 2, 3, 4 dry years, and then this year was just slightly above average for October through July of 2015-2016. In terms of precipitation, we had, this is through the water year, so these are the last 4 water years which really stood out. There's 1934 right there, and a year ago it was warm enough for the water year, October through September, to top that earlier mark. This is for the Sierra Nevada region. It's the mean temperature for October through September. This is just the winter period, October through July, so it covers the winter part of the year. And the temperature, if we add on 1 more year, we're able to get that in there, and you can see it's still it's the same curve as the last one, practically speaking, with 1 more year added on. So we've had about 4 fairly warm years in a row here as part of this drought, which for any other drought in the record on that on this chart is not so warm as the current one. This is a biggie graph but I wanted to point it out. This is last year's graph from the 8 station index that DWR keeps track of. And I wanted to show it because it shows these last 4 years right over here, two that were a little bit higher, two that were a little bit lower. Here's the long-term average in the blue here, which is conveniently a nice round figure of 50 inches. And then we had these 4 dry years in a row, and this is last year as it stood as of the 1st of June, and it practically ended out this way. So it ended out about here last year. So how does that compare with this year? Well, there's some of the same lines are on this graph, but the one of interest was we had, if you followed the blue line here, you know, some steady precipitation, some big events. There was one right there. There was another kind of extended big event in January, also December. And it looks like it's going to probably end up here. 50 is the average, it's currently 57.8 as of a couple of days ago. So this area up here in Northern California is going to end up above average for the water year. Going down a little bit towards San Joaquin, above average. Well, it's been below average. Again, this is through 2015. Been below average. This is about where it ended up last year. And here we are this year, ending up right about average, almost right on the mark for the current water year. And finally, there's a new index that they just put together, the DWR, for the Tulare Basin. And that's coming in just a little bit, well, modestly below average, which is consistent with, okay, that was a moment of meditation. Well, yeah, so this is the snowpack that occurred last winter. And the current, or this year, was this purple line right here. There's the long-term average in black. And we melted out pretty early. You know, this is May right here into June. So, and compared with 2014, 2015, which is the dismal year we had last year. So that green line is last year. The purple line is this year. It's wildly extravagant compared with practically nothing last year. So it's some improvement. This is the snowpack map as of the beginning of March. Precipitation is on the left, and it wasn't too bad over much of the west, and especially the Great Basin, especially the eastern Great Basin. This is only the SNOTEL site, so it doesn't show all of California. And then this is the snowpack. The snowpack was, again, also somewhat above average for this year. In terms of percentiles for October through March, anything in green is in the top 1/3. Anything in the darker green is in the top 10%. So we had above the top third, in the top tercile, over much of the western states here, especially along the west coast states. And the drier areas were down in this region here, Los Angeles on down to San Diego, which is kind of what we don't expect to see from El Nino. From El Nino, you expect to see dry. We expect to see wet down here and dry up here, and it didn't work out that way. As for precipitation, the temperature, I mean, most of the area was above average. We had some wintertime inversions that helped make this area here a little bit cooler, but for most of the year, it's been above average. Anything in the tan color is in the top 10% for October through March. Freezing level over Lake Tahoe, shown here, was middling along, and then it jumped up quite a bit. And then it came back down a little bit. I didn't put that on this graph. Well, it came back down a little bit in the current year. The year before was about 2,000 feet higher than average for October through March for the freezing level over Lake Tahoe. And speaking of Lake Tahoe, the level of Lake Tahoe after that big winter of 2010, 2011 was at this level right here. It can't go over 29 over 9 feet on this scale here, and it rose a little bit, then it would fall a lot, it rise a little bit, fall a lot. This is a drought. it's right about at the rim. It's just barely below the rim as of a couple of days ago. The Colorado River, which matters for parts of Southern California and also Southern Nevada. This is the storage behind Lake Powell, which is currently about 55% full, 45% empty. Water level was 85 feet below normal. Lake Mead, I don't have a graph for it, but Lake Mead has been really dropping quite a bit. I don't have the numbers in front of me. They're a little bit harder to find. And as you can see from these, we watch these towers here, the intake towers, and it's down quite a bit here at Lake Mead. And of course, we have the bathtub rings are still hanging in there. As for the ENSO index, this is a long-term. This is from Klaus Walter and Mike Timlin, and shows the MEI, multivariate ENSO index, going back to 1950. Oops. Well, anything in blue here is you could label as La Nina. Anything in red you could label as El Nino. Here's the El Nino we just went through. It's on its way down now. There's a value right here which might be a little hard to pick up, but it's on its way down into La Nina territory. So this is the current SST, sea surface temperature map, for last week, August 14th through 20th. Anything in yellow or red is above average. There's our developing La Nina right here in this area between the date line and South America. We've got some more blobs to talk about if we run out of things to say. There's a mild blob here, there's a stronger ones up here, and of course the sea ice has melted early up here, so that's why the water temperature is above average. Same thing when we look at the Climate Prediction Center, their maps. This is just focuses in only on the Pacific Ocean, and you can see again this developing El Nino, or excuse me, this developing La Nina between the date line and South America. And you can see the ocean temperature anomalies in these red and yellow boxes have been steadily declining, and they've gone below average, excuse me, in Nino 3 and 3.4, this region right through here. So that's what you're seeing with that blue color that you saw earlier. So the typical pattern that we expect to see with La Nina is dry here and wet here for the winter. And we have some scatter diagrams. We'll just go through these. They're all kind of similar. When we have El Nino, we're off to the left in the red colors. La Nina is to the right in the blue colors. And up here in this region right here in the north coast, what this says is that when we have La Nina, we tend to have, well, there's the correlation here is minus 0.011, R squared is 0.01. Basically no relationship, okay? And this is based on years back to 1933 onwards, so of 80 or 90 years or so. Coming over to Division 2, which is the Sacramento River, very similar picture. There's hardly any relationships to the Sacramento River to La Nina. We'll advance here. Okay, Division 5, which is the San Joaquin River. The correlation improves very slightly, but it's still pretty much a scattershot diagram. If we come on down to the southern coast of California, with the exception of this one dot right here, all of the La Nina years are clustered down here on the dry side. There's the overall mean right there in the green. So La Nina has, with the exception of this one year, La Nina has been very consistently dry in Southern California. And there's the wet years with El Nino that we were sort of looking for last year up here in the red dots up here. Looking at the 8-station index we just showed you, it's a similar type of diagram. R squared is 0.02, basically hardly any correlation with La Nina. The 5-station index, which is these central places near Yosemite and Calaveras, Big Trees, Hetch Hetchy on down to Huntington Lake. Again, R-squared 0.03, very little correlation. And if we move over to Arizona, we have a similar kind of thing as we have for Southern California. They're all clustered. All the La Nina years are clustered down here as being dry winters. Well, I found a problem with this diagram. I don't think I'm going to dwell on it because Dave is probably going to have a better. I mixed up 2015 and 2016. They look the same, and so I believe I'll stop at that point and turn it over to the next. Or if there's any questions, we could take those for a minute or two.
Thanks, Kelly. I think we're going to save questions for the end, so you guys can send those through the chat box, or I see we might have a few in the question box we can come back to later. But that was a great lead into our next presentation, which will be by Dave Pierce from Scripps Institute of Oceanography, and he'll talk about further impacts thinking about La Nina for the region and how it's developing.
Okay, can you see my screen?
And now.
Yeah, now we're good.
Okay, now my icon's covered here by it. Hold on a sec. Okay, so I'm going to talk about the seasonal outlook for this coming winter, and as this audience knows, we have quite a bit of variability year to year, with some years, of course, being relatively wet and some being quite dry, and we have some limited potential to predict these depending on what's happening in the rest of the climate system. So I'm going to talk about that. So the main thing here that I'm going to mention is El Nino and La Nina cycle, as Kelly mentioned. And the reason we harp on this is because this is the most predictable cycle of climate variability that affects winter precipitation in California. So there are other cycles in the climate that are linked to California precipitation and Nevada precipitation too, for that matter, but they're not as predictable. So here we are in the middle of August, so we're talking about El Nino because it has this kind of predictability. So in El Nino, the warm event, here's an example from 1997 where we had a really big one. That's when you get warm water in the tropical Pacific. On the other hand, La Nina, which is developing now, is when you have cold water. And this is an example from December of 1999. And I'm going to use this as a yardstick to compare to what we're seeing this year so you can get a feeling for how it looks compared to a previous event. The time history of El Nino and La Nina is shown in this diagram at the bottom. Here's the 1998 La Nina here. So you can see it's kind of an average, typical La Nina. All right, so how does La Nina affect our weather? And this is actually a still from a movie, which if you have an interest in these things, I urge you to go look at. And the interesting thing about this movie is what it's doing is it's showing a simulation of winter storm systems coming across the Pacific in a typical El Nino year and a La Nina year. So these colored blobs are an indication of where the storm centers are. And if you run the movie, what you see is during the El Nino, there's this systematic deflection southwards, whereas during La Nina, storms come across the Pacific more in a straight east-west kind of fashion. And what I want to point out is that California, if you look at California and Nevada here, it's really quite a small region when you look at these whole world maps. These storms are large and they're deflected only a little bit. And this is really why there's this element of unpredictability to what the effects of La Nina will be on California and Nevada. It's bending these storms, but the storms are pretty big and there's this chaotic weather systems all before them and behind them. So you end up with a lack of predictability of exactly what's going to happen for each storm. It's more the aggregate average that has some response. So the current La Nina forecast, this is how it is usually presented here. I'll talk you through this. So this is December, January, February, so this is our upcoming winter. And each colored line here is the prediction of one particular model, over here on the right, of what the ocean temperatures will be in the tropical Pacific. So if this hits minus 0.5 Celsius, that's considered a La Nina. So you can see that here in our winter, the majority of models are predicting a La Nina. The average is this kind of yellow highlighter color here, but you still have a spread. So if this was just a climatological year, this model swarm would be centered on 0. Instead, you see it systematically deflected to the cold conditions, but of course you do have around the center predicted value because weather has this unpredictable chaotic component to it. Now, the way that's usually summarized is in this rather busy figure here. I'll just show one column. This is winter, this coming winter. And the climatological averages for El Nino conditions here are shown in red, La Nina in blue, neutral in green. And the prediction for this particular year is shown in the bars. So I've summarized that there because I always think it's a little hard to pick that out of that picture. So climatologically speaking, if we had no other information, you have about a 35% chance of a La Nina in any particular year, 30% chance of neutral, 35% chance of El Nino. But this year, this coming winter, we have about a 57% chance of a La Nina. And again, understand that these are model predictions, so there is some uncertainty there. But 57% chance represents about 1.62 times the normal condition chance of getting a La Nina. We also have an enhanced chance of neutral conditions, about 1.27 times the typical value, but much lower than normal chance of an El Nino. Almost none of the models, matter of fact, I think probably none of the models show that the La Nina will continue into this winter. So this is a way of looking at the probabilistic nature of the El Nino La Nina prediction. We have about 62% more chance than usual of a La Nina coming up this winter. So let's look at what's actually happening out there at the moment. This is similar to what Kelly just showed you here in the red box, but I want to compare it to another year as well. So here is just looking at this strip in the tropical Pacific where the ocean temperatures matter for El Nino. Here are current conditions from last week, and this is in degrees Celsius. The cutoff is 0.5 Celsius colder than usual over a region about here. So you can see that it's cold enough, but it hasn't quite extended to the full region that we would consider a well-developed La Nina at this point. Now at the beginning, I showed you a picture of the 1998 La Nina. Here's what the ocean temperatures were in August of 1998. Now that was a pretty much average kind of La Nina, and you can see it's much more developed at the comparable time of year than our current La Nina is. This is one of the reasons why I think if we actually end up having the La Nina, it's going to be a pretty mild one. You know, compared to this typical one before, that was way more advanced at this point of the year than we're seeing now. So just try to keep that in mind. Now another aspect of La Nina, which I think is pretty interesting, is what happens beneath the ocean's surface. And this is actually, if we were to go into the physics of La Nina, which I'm not going to do here, this is what determines the event. So I've drawn this funny looking picture here to try to indicate I'm showing a slice from the surface of the ocean down to depths. So here's the slice. This is temperature departure from normal conditions in this slice. So surface here down to 500 meters depth, South America over here and Indonesia on the left. And what you see is you see cold water conditions below the surface of the ocean, and that's very typical of La Nina. These cold anomalies start over here in the west, propagate across the east, then break out in the surface, and then that gives us our La Nina. Now, the 1998 event, at the same time of the year in August, you can see again much more developed. So this is another, literally more in-depth way of looking at the strength of the current La Nina and how it's developing compared to this past event, and you would conclude that it looks like it's a pretty modest event at this point. Now the average effect of La Nina on winter precipitation here I'm showing in map style, and so these sort of brownish colors are up to 30% drier than usual on average. Now again, Kelly showed you those scatter plots, so you have to keep in mind each La Nina is a little bit different, but this is the average response. And for our purposes here, you see there's actually very little response in Northern California. So that's why you're getting those, or maybe it's better to say it's just another way of showing what Kelly said, which is you get poor regressions between La Nina and actual precipitation in this part of the state because there is no average response. Now in Southern California, that's not true. You do get an average response, but it's even stronger over here in Southern Arizona, New Mexico, and Southwest Texas. and Florida for that matter. Now, some people are concerned about temperature effects of La Nina. They tend to be opposite the El Nino effects. Again, in California, not too much of a response. There's a little bit of cooler than usual conditions in Northern California, but remember, this is the average and there's a lot of year-to-year variability. You get the biggest response by far in the upper Midwest, where it tends to be colder than usual during La Nina, and southeastern U.S. tends to be warmer. And this actually has a pretty noticeable impact on the people who live here. People have looked at the effect on heating bills and deaths from auto accidents and so forth. These cold conditions do have a real effect, unfortunately. One interesting question that I think is, how does an average La Nina year compare to the 4 years of drought that we've seen before this current year? So here is the average La Nina response. I'm just plotting this again so we have it here in front of us. And here on the same color scale is the drought from 2012 to 2015. It's actually maxed out here. It's a little bit drier than that. What you see is they're not really that similar because the drought had a quite strong expression in Northern California, whereas La Nina does not. The drought had an expression in Nevada, whereas La Nina is slightly wetter than usual, but not significantly so in Northern Nevada. So they're really somewhat different patterns. The drought, as you probably know, is mostly forced by this high pressure ridge off the western coast of North America, whereas this is forced by these conditions in the tropical Pacific. So it's different forcing mechanisms to some degree. Let me go ahead and summarize. So right now it looks like we have an enhanced chance of La Nina, which is cooler than usual tropical Pacific ocean waters. The current estimate is that we have a 57% chance of La Nina, and that represents a number that's about 60% more likely than usual of it happening. But keep in mind, these are probabilistic. We also have an enhanced chance of a neutral year, so about a 38% chance, which is 27% more likely than usual. But a little chance of an El Nino continuing, maybe about 5%, but the current conditions are actually showing that it's pretty much died away. Now, each La Nina is different, so each response is going to be different, but on average, we get about 10 to 30% drier across the southwest U.S., especially in that band through southwestern Texas, New Mexico, Arizona, and Southern California, 15 to 20% drier in Southern California, mostly drier in Southern Nevada, wetter in Northern Nevada, but that's a fairly modest response when you get to that far north, and no consistent effect in Northern California, which is where most of California's state water resources come from. Current ocean conditions we're not quite at La Nina yet, because you have to reach that minus 0.5 Celsius threshold over a pretty broad region of the central tropical Pacific. It's actually gotten that cold, but in a more limited region at the moment, so we have to see if that spreads. And when you look at the comparison from a pretty normal sort of La Nina of the 1998-1999 event, that event was stronger at this point in the year. So to me, that's consistent with the idea that, if this La Nina actually makes the bar of the 0.5 C threshold, it will probably be a pretty weak event. And lastly, I want to mention that the recent 4 years of drought have been drier than the average La Nina, especially because in California, we get so much of our water resources from the northern part of the state, and the La Nina has little systematic effect there. Okay, so go back to Amanda.
Thanks, Dave. And again, we've got a bunch of questions coming in. We're going to just save them for the end. I realize some of them are probably addressing the first two presentations, but hopefully then between Kelly and Dave, they can answer them then. But now I'm going to pass it over to Mike Anderson, who's our state climatologist. And he's going to talk about, he's the California state climatologist, and he's going to talk about impacts to California that he's experienced and groups he's been talking with.
All right, here we go. So we'll start with the most recent executive order on water conservation, and this one directed the local water suppliers to submit to the State Water Resources Control Board the results of a stress test saying what their supply would be adequate if you had a repeat of the past 3 dry years on their system. And 379 suppliers submitted results. 36 indicated that there might be a supply shortage in 2019. Statewide, the water conservation in June was at 21.5%. Not quite the 25%, but still doing quite well. The summer of this year, the Save Our Water Conservation Campaign launched the theme, Water Conservation, It's for Life. And this follows the Governor's Water Action Plan's first action, which is make water conservation a way of life. Moving on to the next slide, we'll look at some of the local statistics and what's been going on in terms of the response. So we have 25 local emergency proclamations from counties and 10 emergency proclamations from cities and 12 from special districts, 10 from tribal nations. And the main purpose of these proclamations is this is how they get in line for financial assistance for different projects. So given that's where we're at right now, and just for reference, the state has 58 counties. So not quite half of them have a proclamation. So if we look at the statistics on the financial assistance on the next slide, so there have been 176 projects submitted. 122 have been approved for emergency funding, and those have been executed by the State Water Resources Control Board. The latest round has $19 million in emergency appropriations, and requests to date so far at $15.4 million. As you might have heard in the news, the department began connecting homes in East Porterville to the City of Porterville's water system. This takes people who are on private wells that are either dry or contaminated, and then gives them now a source of water beyond what they had been using, which were large tanks in their front yard that were where water was hauled once a week. So anyway, so this particular effort was about $16 million, and there are several other emergency construction projects for hookups in Tulare County. Tulare County is probably where we see most of the challenges coming in terms of small water systems needing emergency assistance. And then as far as food assistance for the farm worker communities seeing a high unemployment, that includes Fresno, Kings, Tulare, Kern, Merced, San Luis Obispo, Santa Cruz, and Sutter counties. So you have that kind of swath in the southern San Joaquin and Tulare Lake Bed region, but then also a little bit still in the Sacramento Basin. All right, let's go on to the next slide. All right, so here's some of the latest statistics on some of the turf replacement and toilet retrofit rebates, some of these to motivate improved water conservation at the household level, and you can look at the statistics there in terms of how much money has gone into these different activities. 21.8 million in turf replacement, 5.2 million in toilet retrofits, and you see the applications submitted and how much of the funding remains. And that program started actually a year ago, so that you're just looking at about a 1-year run on those two activities. So let's go to the next slide. All right, so the next big one, and one that's certainly on everybody's mind about this time of year, is the wildfire risk. So the governor launched a tree mortality task force this month, and they're looking at mapping and monitoring the resource utilization regulations and looking for ways to try and harvest some of the dead trees, and looking at going with the bioenergy grants through the Energy Commission. CAL FIRE reports 4,000 fires covering 150,000 acres this calendar year through August 20th in the non-federal responsibility areas. Now, this is where you have, so this would be the fires not covered by the federal interagency fire group out of Boise. And so we have 3 large state jurisdictional fires. There are other large fires that are under federal jurisdiction. And so these are the state ones. So when you look at fire statistics, you have to look at both the state fire statistics and the federal fire statistics. There isn't currently a way to view both. And so if we go to the last slide, then we'll take a look at a mapping of the tree mortality, which is heaviest in the San Joaquin, West Slope Sierra, down into the Tulare Lake bed region. And this is where we've seen the highest density of the dead trees. And this is also the area that's been some of the hardest hit with the most recent drought. And with that, I'll go ahead and end my section of the webinar and hand it back to Amanda.
Thank you, Mike. With that, I'm just going to pop up back to our last question and answer slide. While I'm doing that, I'll note that we've had a question about getting these presentations. They'll be posted online on drought.gov within a week. If you need it sooner, you can contact me at Amanda A.M. Sheffield at ucsc.edu. It's also on drought.gov. Sorry about that. And we're going to answer a few questions. Alicia, do you want to grab the few questions while I pop this slide up real quick?
Sure. So I think we'll go back. We've had a few questions that may be more applicable to Kelly and Dave. So either of you feel free to answer. We had a question asking if there's any evidence yet of atmospheric coupling with the emerging La Nina. You may need
well,
to
that's typically measured by the multivariate ENSO index that Kelly showed, and at the moment that has not dropped into typical La Nina values. So as of this point, the answer would be no, it's not there yet, although the models predict that there's this chance that it might come by this winter.
Great.
Yeah, and it's heading that way, but like Dave says, it's not there yet. But it is moving in that direction.
And then we had another question about the skill of the models that are being used to measure La Nina. Are there any that you may consider more skillful, and if so, which, what are they suggesting in terms of predicting a La Nina?
Well, there's 2 kinds of models that are used to predict this. Roughly speaking, statistical ones, which use statistical formulated predictive based on past history, and dynamical ones, which were more like a weather model. And in the past few years, it's been found that the dynamical models have overtaken the statistical models in their predictive skill. So the results I'm showing here are just from the subset of all models, which are the dynamical models. But you can find all the model results on the website if you're interested in them.
Great. Okay, I'm just going to keep going. So how would you characterize the ENSO index average from 2012 to 2015?
I think Kelly had a picture of that.
Let's see, I'm trying to think what that would be.
You had the recent MEI, right?
Yeah.
Kelly, would you like me to pass the screen back to you?
Maybe, yeah. I think if I've got it right. Okay. Is this what you're after? What you're asking about, this graph right here? Move this out of the way. This is what you're referring to, Dave?
Yeah, I believe that's what the question was about.
Well, as we've been noting, I mean, there's this El Nino has pretty much run its course, and you can also see that from this. There's no hint anymore, either from this information or from the last. There's two sets of sea surface temperatures I usually use to track this. This map here comes from Esrel, the lab in Boulder. It's a NOAA lab, Environmental Sciences Research Lab, I think is the name of it. Is that right? And this is a global map. And then when we study El Nino, La Nina, we generally focus in, and CPC, the Climate Prediction Center, has just sort of focuses in on this area right here, and you can see this sort of developing area right here of, if you track this in time, and that's what this does. You sort of combine the left-hand graph and the right-hand graph. This is a time series of what's happening in different parts of this graph, which you use this this set of this little legend down here to interpret the other two sets of figures. And basically, we have in recent years tended to focus in on this area. Originally there was Nino 3, then there was Nino 4, and they thought combining parts of 3 and 4 in this area called 3.4 is probably the most productive, at least for now, synthesis, the most distilled information is 3.4, and so that's this diagram right here, and you can see it's gone a little bit below average, and that's the blue here corresponds to the blue here. So that's why we're saying it's heading in that direction, but according to those figures that Dave was showing with the looking out into the future and all the different models and so forth, this hasn't come down quite far enough for long enough over a big enough area to qualify as what would go down in the books as a La Nina.
Okay. Thanks, Kelly and Dave. A little team effort there. We have another question about, just closed it, what the outlook is for the RRR, the ridiculously resilient ridge, I believe, in the coming year.
Well, I guess the one answer I would give, and Dave might have a little bit different take, but they're kind of one and the same. In other words, it's through the action of this ridge that we have gotten the dry conditions that we've had. So it's in a funny way, it's sort of like saying we've had the conditions that cause drought, and the explanations are going to have to involve a ridge of some sort, and they are built into these model calculations that Dave was talking about. That's how they work. That's how they do it. They try to simulate what's going on in the atmosphere, including the presence of this ridge and its evolution in time. And in order to make this prediction, that ridge has to show up in there, because that's the mechanism by which it operates.
I guess the only thing I would add, besides everything that Kelly said, which I agree with, is that there has been a lot of interest in that ridge over the past few years, as you can well imagine. And my guess is that you will see starting to come online explicit predictions of that ridge, but we're not there yet. And I actually looked around, but I haven't been able to find any group that's doing operational predictions of what that ridge might be in the coming winter.
Okay. Great. Well, I think that should be helpful. Oh my, we have a lot of questions. Okay, so we have 5 minutes left. Um, and let's see. I think there's some questions about the role of climate change in the current drought, and maybe also its impact to the relative strength or maybe the changing conditions with El Nino and La Nina. I'm kind of trying to lump a few of these together in the interest of time. Does anybody feel comfortable?
Well, I will give a stab at that, although these are research questions. I hope it's understood, so we don't know the final answer yet. If you look at the temperature trends on what effect it has on the aridity of the surface soil, and analyze a bunch of model predictions of how that is likely to change in the future and how it's been changing since the pre-industrial era, you come up with this estimate that the warming has probably made this magnitude of drought, say 25 to 30% more likely to happen than if we hadn't had this warming yet. So again, it's probabilistic. You can't, in our current scheme of understanding, you can't say that this drought was absolutely due to or not due to climate change, but you can say that climate change made it sort of 25 to 30% more likely for this magnitude of drought. And as far as the effect on El Nino and La Nina, the current thinking is that what climate change is going to do is move the center of action of El Nino and La Nina more towards the center of the Pacific. If you remember when Kelly was talking about those different boxes which you look at El Nino in, historically El Nino has been more towards the coast of South America. And it's believed that in the future, at least the models are fairly consistent in showing a systematic movement more towards the center of the Pacific. And the reason that actually matters to us is because you get a stronger connection between what happens in the western U.S. and temperatures in the central part of the Pacific rather than temperatures near South America.
Great, thanks, Dave.
I don't have much to add to that. I pretty much agree with Dave's the 30% figure, something like this, that it's a contributor. I guess one little thing I might add is that the temperature component, as usual, seems to be a little bit more tractable to deal with than the precipitation component of drought. And you know, it's been a feature of this current drought that temperature has played a big role. There have been a lot of really warm conditions, and that is easier to tie into climate change issues, I think, than changes in the pattern of precipitation. Which is just a harder beast to deal with.
Mm-hmm. All right, I think that's really helpful. We have 2 minutes left. I may throw in one last question. It looks like we have about the existence of the blob, is coined by Nick Bond, but Utah, of warm water off Washington State and Canada. Did it temper an otherwise, what may have been a stronger El Nino last year? And do you think it'll affect the coming La Nina and weaken it?
Well, Dave's the oceanographer here. I defer to him, but I do have a little comment to make.
Okay.
Sure, go ahead, Kelly.
Oh, okay. Well, now I lost my train of thought. Yeah, you have something, Dave?
Well, I was just going to say that primarily, I mean, again, climate is all interactive, so it's hard, you can't make these absolute statements, but primarily the blob was a response to the atmosphere. It didn't cause atmospheric changes. So, high atmospheric pressure, decrease in winds, more sunshine, less cloud formation, all those things cause the blob primarily. It's not that the warm water caused the high pressure ridge. So it's not that, it was more of a response than a cause, is what I'm trying to get at.
So yeah, so I remember my comment now, which is that I think one thing we're really going to have to look into the El Nino that we had last year, and now followed by probably a La Nina. um, means that the role of these blobs is we're going to have to figure it out better. Are they really having a role or not? And this is going to involve a lot of experimentations with and without, and putting them in different positions, and sticking around for a certain amount of time, and how are they interacting with the other features of the climate system? Because we always have several things going on at once. Unfortunately, we never have only one thing going on in the climate system. There's usually a half a dozen features that we can point at or that we're interested in. And I think a better understanding of the role of these blobby features, since we haven't seen too much of them for a long time, I think this is a research area that we really need to put in a lot of attention, just to say, are they something or are they not, in terms of predictability and our ability to say something about the upcoming season.
Great. All right. Well, I'm going to pass it over to Amanda to wrap things up.
Yeah. So first I want to thank our speakers. If you have further questions, you can contact us, the organizers, or the speakers directly. Those were Kelly Redmond from the Western Regional Climate Center, Dave Pierce from Scripps, and then Mike Anderson from the Department of Water Resources, who's our state climatologist of California. I just want to remind everyone, so this is actually going to be a series of webinars we're going to host throughout the water years, providing updates. So the next one we have scheduled for Monday, November 28th. You'll see a quick survey when we close the webinar, so that'll give you a chance to tell us what you didn't hear today and what you guys might want to hear next time. Otherwise, we'll hopefully have the same format with providing current drought status and the update as we launch in further into the water year. With that, thank you everyone for listening, and hopefully you can join us next time.
Thanks a lot, Amanda.
Yeah.
And Alicia.
Thanks.